Hello. So now we'll be solving question number 27 from phase 1 book from the chapter Forces and the Laws of Motion from exercise. So let's see this question. A particle moves in a circle of radius 4 centimeter. The radius of the circle is given 4 centimeter, or you can say 4 into 10 to the power minus 2 meters in clockwise direction. So this motion is in the clockwise direction at a constant speed of 2 centimeter per second. The critical part here is constant speed. Since the speed is constant, obviously the speed will be tangential because it is circular motion, and that is given 2 centimeter per second, which you can convert into the meter. So 2 into 10 to the power minus 2 meter per second. And it is constant. Since the Vt is constant, the At will be 0. If the speed is not changing with respect to time, there is no tangential acceleration. If there is no tangential acceleration, then the acceleration in this case is only AC. So net acceleration will be equals to AC only in this case. And when it comes to the AC, it is towards center. So direction of AC is always towards the center, and the magnitude wise, the AC is Vt square by R. Vt is given and R is also given, so you can always go for it. So 4 into 10 to the power minus 4, that is Vt square, divided by R, which is 4 into 10 to the power minus 2. That comes out to be 10 to the power minus 2 meter per second square. That's the acceleration. Now, rest of the question. If x and y are unit vectors, generally we call them I cap, j cap. So they are calling it x cap and y cap, okay? X cap, y cap are the unit accelerations vectors along x-axis and y-axis. No issue, respectively. Find the acceleration of the particle, this acceleration, at the instant halfway between P and Q in the figure. So this is the figure. So we have to calculate the acceleration, not along tangent and the center or radius, but in this case, they are asking us the acceleration in terms of I cap, j cap, or x cap, y cap. Okay. We already got the acceleration. So all we have to do, take the components. So let me make the diagram. So this is point P and this is point Q, and they're saying exactly midway. This is the midway. The angle is going to be 45. So when the particle is midway, only acceleration it has is AC, and the direction of AC is always towards the center. So this is AC. This angle will be 45. This vector is x cap and this is y cap. So this will be minus of x cap and this will be minus of y cap. So I need to define the acceleration in terms of x cap and y cap. So it's pretty simple. The acceleration will be equals to this acceleration. I'll be taking the component. So it will be AC cos 45 along this minus x cap plus AC sin 45 minus y cap. That will be 1 by root 2, that is a sine cos 45 into 10 to the power minus 2, and minus I have to put it outside, x cap, and minus of 1 by root 2, 10 to the power minus 2, y cap. That is the acceleration. So we have calculated the acceleration in terms of tangent and radius, and then converted it in terms of the desired one, which are x cap and the y cap in this case. Okay. Thank you.